All right. Hi, Satra. Nice to see you.
Nice to see you too, Mac.
Yeah. So, why don't you tell people a little bit about yourself, who you are, where you work, and what you're interested in?
I'm Satrajit Ghosh. I work at the McGovern Institute for Brain Research at MIT. My group kind of focuses on mental health as our North Star, and I'm a computer scientist and a computational neuroscientist by training. So I'm not a psychiatrist, I'm not a clinician, but we find this place complex enough that we can bring to bear many of the tools to understand how we might solve some of the challenges that people are facing day in, day out around the planet. So we kind of focus on a few areas. One is understanding the neurophysiology of human communication. How do we generate speech? How do we talk to each other? What kind of information lies in our voices and our texts and our chats that relates to kind of mental state and brain health? We also kind of take various kinds of sensors. I've been in the brain imaging world for a long time. So we take things like brain imaging and other things and say, okay, what could we predict from that kind of information? How is information organized around the brain? So we do a few things around precision medicine and psychiatry. And then as we've gotten into these spaces, we realize we're searching around for data. And so a big chunk of our work over the last couple of decades has been to build out repositories, to build out analytical pipelines, to build out ways in which we can organize information and to disseminate it to the planet. So that's what we do.
Awesome. Yeah, I've always really admired your work, Satra, and you're one of those names that keeps popping up on all these different projects that I read of and I see, and I go back in my revisionist history of the field and be like, Satra was involved in that too. So you're one of these people that I think really invests in the community, and I really admire that. Um,
I
so.
love that notion, right? Because the community is what gets us together.
Yeah, absolutely. And I think so. For those that aren't aware, Satra and I met through the Organization for Human Brain Mapping, which is this really fascinating conference that brings together people from lots and lots of different areas that are all interested in this problem of trying to map the brain, this kind of very sort of nebulous concept. And so you find people that come from fMRI, people from EEG, there'll be clinicians, there'll be engineers, there'll be software enthusiasts, all these different types of people, this sort of melting pot, and it brings them all together. So, Satra, when did you first start going to OHBM? I think you've got a slightly longer tenure than I do.
My first OHBM was 2001 in Brighton, England. And I was a grad student back then. And it was the first meeting. And just as a community, it was an amazing meeting from a scientific perspective. But I think what was different, because my first conference ever was a Society for Neuroscience conference. And you know how easy it
Wow.
is to get
Oh yeah.
lost in a sea or
Oh
an
yeah.
ocean of posters and people.
Oh yeah.
OHBM was different. It seemed like a very close-knit community that was talking to each other. They welcomed me in, and that's how my journey in the imaging space began.
That's awesome. So you've got about 10 years on me. My first was 2011 in Quebec City. And aside from stuffing my face with poutine, I remember feeling the same thing. I was this little graduate student. I didn't know anyone at all. I think I'd emailed Nathan Spring once beforehand, so he was like the one person I knew. But I immediately got into these great conversations at the poster session, and it didn't feel like I had to prove myself. It felt like I was there to learn from people, and it was very collegial. So I really love that community, and I've been going basically ever since.
Yeah.
And so OHBM is this great community, but like all communities of scientists, we face this kind of information deluge. I think maybe the SFN example you gave is an even more pertinent one. You walk through a poster hall at a modern conference, and you are just inundated with this information, right? It almost feels if you kind of walk through passively and just read the words on these titles, you often sort of find these completely different terminologies on different posters. This one will be about viral track tracing of some archaic brainstem structure, and you'll turn the corner, and now you're doing whole brain modeling, EI modeling of a neural mass model, and it's so hard to find the kind of link between those. I was wondering if you've had that same experience at these conferences. How do you find that kind of overwhelming nature?
Absolutely. I feel that as scientists, a lot of our time is spent understanding the words we use. And I don't mean English as a language. It's these technical terms and spaces that come to bear. And every conference is full of those, right? And you live in pockets of these words and spaces in your own, whether you're a student, whether you're doing research in the space. And when you go to one of these, in fact, I read a title of something and I realized I knew four words in the title, and those were the, and those. Uh, and so it's in science, we are completely inundated by jargon, well, so to speak, but they're not jargon to the communities that study them. They're
Yes,
just their
exactly.
lifeblood. And this is, I think, common in every conference, and especially when I was a younger student. I didn't have a background in neuroscience. I came into the world with a computer science background. And so the world of neuroscience itself, the brain anatomy parts, the notions of disorders, was all foreign to me. And
Yeah.
so coming to a conference and then you'd say, oh, fMRI. Well, I knew what fMRI was because I was doing some things in that space. But there's a whole host of technologies that come up in a space like OHBM that you never use. And
Yep.
it takes a while to get used to what the connections are between the
Yeah.
techniques, the questions, and the people.
It's funny, we have almost the polar opposite experience, but with exactly the same outcome. I came from the world of medicine where I knew a lot about brain parts. I could tell you all the cranial nerves and what the different syndromes were. If you had a stroke in this one area, what would the side effects be, or something like that. But then when I came to human brain mapping, I was just inundated with linear algebra and talks of all these different complicated computer programming softwares that I didn't know anything of. And so it's almost like the two things that we had as our backgrounds were our tether, and we were both facing the same level of complete bewilderment at this kind of like overwhelming technology and terminology. Um, so it's fun to think about that as a challenge, but it's very hard to solve it in practice, right? It's difficult to meet a person that has a completely different background to you and immediately get on the same page and have a pertinent, meaningful discussion that actually gets to the crux of an issue. And I think that's one of the really big problems we're trying to solve.
And and I think it's a perennial problem, right? It's we dig ourselves into very deep spaces when we are thinking about a problem space, and we get embedded in thinking through a very narrow slice, all the holes in our thoughts and questions that we need to answer. And when you're
Yep.
taking a zoomed out view at that same thing, it's a whole different shape that you're looking at. And I think this is exactly why conferences are fantastic. It
Mm,
allows an opportunity to enrich ourselves and this terminology that comes across every time we go. And I've always felt that lifelong learning that I've had. And today I understand a little bit more than I did back when I was a grad student. But it's
yeah.
thanks to being able to look at some of these posters, talk to people, and be able to try and get some kind of brain alignment.
Yeah.
Maybe a
Yeah.
pun was intended there, but
No, no, I like the idea. That's awesome. So I'm glad you brought up this notion of zooming out because one of the recent a paper that just came out a little while ago, and I actually had the pleasure of interviewing Mario, is actually something that you and I have discussed together as a really interesting kind of strategy for showing us this field at a kind of bird's eye view. And so, for those that aren't familiar, Mario is a neuroscientist, computational neuroscientist working in the Netherlands, and he used a bunch of the power of these kind of new large language models to help him sort of sift through, essentially something like 500,000 abstracts from the field of neuroscience in the last few years, and then use the a bunch of clustering techniques to kind of whittle these down into kind of hopefully meaningful little clusters. But what you could then do is with that bit of fuzziness that always comes from clustering, you could now see the field as a whole, and you could ask yourself, okay, how similar semantically are the fields of psychiatry and neurology, or are fields that use fMRI versus EEG, or that use animals versus humans as their test subjects? And you can, it's not a perfect tool in many ways, but it also is really helpful because it lets you see this bigger picture. So I'd love to hear kind of what you thought when you first read that paper and saw that. Was this kind of music to your ears? You've obviously thought like this for a long time, I think. So yeah, I'd love to
yeah,
hear your thoughts.
it was fascinating to see, and again, the serendipity in science that we got connected through that paper
Yeah,
has more tentacles that we'll probably talk
yep,
about soon. But in the context of that paper, the ability to kind of give shape and space to information was what it was about. It's like looking at a
yeah,
map. Everybody kind of looks at Google Maps or others to know where Boston is in relation to Sydney, for perhaps. Maybe very few people do that. But uh, we kind of get a sense of relationships between places, between physical features like where the Rockies are and how are towns situated around it. And
Mm,
Mario kind of did that same thing, but with abstracts from neuroscience,
mm,
to be able to say, how are different components of the field related to each other? And could we lay this out in a way that kind of makes sense uh, to maybe visually explore or to categorically explore? Because we deal with kind of small changes between things, understanding slight differences. But as humans, we like categorical perception. I think our brain likes it. So when people lump things into categories and says, "Hey, there's a cluster of information that belongs to,"
relax.
it
Yeah.
helps us relax and calm
Yeah.
down a little bit.
Yeah.
Uh,
Yeah.
and I think Mario approached this through a mathematical lens to be able to bring
Yep.
these things together. And I'm very thankful to that because that seeded many downstream things as a result of what he did.
Yeah, well, that's a great segue into where I wanted to go next. Because one of the things that I've loved about human brain mapping in particular, and it might just be because it's the conference that I've been fortunate to attend over the years, but I do think it's a special element of OHBM, is that the community is very constructive in the sense that if someone has a tool out there that can do a certain thing, but you'd like to achieve a certain other thing that's maybe adjacent to that, they're very willing to share their code with you and help you construct that next tool. It's very much focused on the next question rather than the past. And so, with that spirit in mind, I was really excited to see that you were actually thinking about taking what Mario had done and sort of adjusting it and shaping it so that it could be useful for the human brain mapping community. So, do you want to maybe tell us a little bit about your
Sure.
OHBM
And maybe
abstract
I'll give a
atlas
little
and
bit, yeah,
yeah.
I'll give a little bit of background to this
Oh,
as
please
well,
do. Yeah,
because
yeah, that would be
uh,
great.
this wasn't the first time that we kind of talked about this. So maybe our first effort ever was in 2017, the Vancouver OHBM conference.
Yeah, great
And
conference. Yeah,
one of the challenges, and I think this is where we look at problems, right? Whether it's in analytics, whether it's in data, whether it's in scientific questions. And as you mentioned, this is one of the reasons I love the OHBM community. There's so many people and interested in helping out and solving some of these things and extending
yeah.
uh, the community as a whole through solving some of these problems. So in 2017, we were faced with perhaps not a great search engine that allowed us to look at what was being presented in at the conference. 2017 is definitely not 2026. Many things have changed between those 2 years. But we felt as a community of people, we were participating in what OHBM kind of started and originated, or members of the community started a brain hack, which is a
Hmm.
hackathon that takes place right before the conference. There's going to be one this year as well, before the conference. So we got together, we were given access to the abstracts, and we put up a little search site in about 2 to 3 days, which allowed us to search through the abstracts. But
Mm,
this notion of search is really about how do we make connections, right? How do we find things of relevance and interest that we might go through? So
mm,
over the years, there's been groups of people, and I can name several people. Anisha was one of the first people, Dylan, Adam Thomas, Daniel Handwerker, who are at NIH, Tom
mhm,
Nichols, and
mhm,
others kind of along the way. We've kind of kept coming back to this. Could we make the connections between people and posters stronger
mm,
through
mm.
some technological way of looking at that landscape?
Yeah.
Uh, and this year, as you may imagine, we are in a very different time and space with respect to technologies that are out
Yes,
there.
yes.
And what Mario did in kind of mapping information as a point in some space that allows us to relate it, we're able to leverage that and kind of say, okay, how are abstracts that are going to be presented connected to each other?
Awesome.
I will say one of our original goals was to see if we could do a better layout of posters at the conference itself. I'm sad to
Yeah.
say, because of various circumstances, we weren't able to get that. So if anybody blames the layout, please blame me. Uh, but hopefully, one of the things we have built will help you still create connections on top of that.
Yeah, that's amazing. I love this idea of a sort of crack team of people trying to figure out how on earth can we make this problem easier. And it's a funny but very physical problem. Like posters are these big lumbering things that you have to bring in a tube and put up and paste up onto the boards, and but they have a physical location, and that location changes throughout the week. There'll be day one, someone's here, and then day three, maybe they're over there, and so it's a very constrained physical problem. It's probably a hard problem to solve as even just as a sort of diffusion process. Like, what's the most efficient route to even see every poster? Now you got to pick a subset. I imagine that mathematicians would love these kinds of problems.
Absolutely. And it's funny you say that because a colleague of ours who you also know, Daniel Margulis, and I
Yeah.
did some work on something called diffusion maps, a mathematical technique to kind
Yeah.
of look at flow between things. And the first thing he asked me was, did you use that for doing so?
Of course he did. Everything's a gradient.
Yes.
That's amazing. Did you?
I did, but
Uh,
maybe I should explain what we're talking about.
of course,
So
we'll come to
yeah,
that afterwards. That's a good point.
yeah.
Yes.
So
Yeah.
so we got access to these abstracts, and we kind of wanted to say, could we lay them out? Could we create connections between them so that, nearby posters were somewhat kind of coherent in the topics they were studying that would bring people together? And I can't tell you how many times I've made friendships through just the next person standing next to me who was
Yeah.
showing something in a poster. And you get to talk to people, and you create connections. And I've
Yeah.
made lots of friends over the years through that process. So I was like, okay, could we do that again through this lens of mathematics? And that's what led us to kind of create a semantic, a meaning related space between posters through this mathematical lens that Mario had created. So he created a way to put information in in a neuroscientific space somewhere as a point in an atlas, a map. Uh,
Mm, mm.
and we wanted to see if we could use that map to better lay out the posters. I think we'll get there next year to do a better job. But we now have a virtual space, which is the OHBM Abstract Atlas that we've put out there, that people can use to find relationships between posters or topics they're looking for and where they're situated.
Yeah, excellent. So I want to hear more about this virtual abstract atlas. So you took Mario's landscape, this sort of semantic space, and obviously the field of neuroscience is broader than the field of human brain mapping. Even though we are a diverse community, we don't touch all of the corners. So how do you know which parts of that information space are relevant for the semantic topics that actually come up in the human brain mapping, which will have maybe more density in certain areas like the particular time scales of cognitive neuroscience tasks, or the 10-minute resting state set or something. How did you sort of tackle that problem?
I, so, without going into too many details in terms of the math behind it, the first thing we did was take every abstract, run it through Mario's model to give us a point on an atlas map, right?
Yep.
Uh, and we were able to then take those points and create, just based on the OHBM abstracts, a sense of relationships and lay them out in as a
Nice.
flat atlas.
Okay.
So this does not relate to the broad neuroscientific space at the point. It's just saying, how are these abstracts that are going to be presented at OHBM related to each
Yep.
other? So it was
Yep.
kind of a very practical thing because remember, we were trying to solve the layout problem uh, first. As we did that, it became clear that we need to now situate this conference in the context of neuroscience more broadly speaking. So we were able to, again, take what Mario did and able to project this point that we had in OHBM to a point on the map that Mario had generated. So we took Mario's high dimensional space and flattened it out into a two-dimensional visual location. Also a
Mhm.
3D because glitzy things help people navigate some of the elements that you see. It helps us
Yeah,
see
isn't it,
shapes. Uh,
what was the old rule, Satra? If you plot your brain activity on a brain, that's great. If you make it 3D and spin, that's even better.
Absolutely. Uh, so we were kind of trying to do this where it's like visual information helps people navigate all kinds. That's why we have maps and atlases. And flattening it into 2D helps out to see some of the relationship. You lose certain things, but it allowed us to project OHBM as a conference, the abstracts that are going to come up in the next couple of weeks, into this broader space of neuroscience from 99 to 2023 that Mario had mapped out. And it's amazing to see that a lot of OHBM, as might be expected of a neuroimaging conference, kind of sits in one corner of that space. But
Mm.
what's really interesting, and this is what's intriguing about any conference, right? They're projections or dots, they're places, kind of cities or towns in OHBM that are all over this map of neuroscience that are different. And you kind of are seeing this connection to this broader world of neuroscience coming in. Yes, most of it is in, let's say, California, but there are many things around the country in various cities. And now you can take a look at that abstract and situate it in the context of a set of papers, sometimes thousands of them, written over the last couple of decades that you can now relate that one abstract to. So it's really about creating this connectivity space as a practical way of kind of connecting the dots between neuroscience and what's going on in OHBM.
Yeah, that's fantastic. And as someone who is geographically isolated from the majority of the community for much of the year, it's really nice to be able to place yourself now in a semantic space and say to yourself, actually, even if I am working over here, geographically, conceptually, I'm actually working in this space with a lot of other contemporaries that I can go to. And I really love this notion of maybe there's a feeling of connection that can come from that because you're actually working on the same problems together, or maybe using the same terms, which is a really cool thing.
Absolutely. And it's one of the things we did with the atlases that I have fun with is every time you go to this virtual abstract site, you'll get a different set of random abstracts thrown at you. Because I feel that serendipity plays a role in a lot of science,
Yes,
and maybe
yes,
somebody sees a title, it's attractive to them, and we dive and go into because often we sit in our own corners and cubicles of the semantic space. We study something deeply because there's so much to know about what we study that we
yeah.
keep digging in this place. I also feel that when you kind of open up your mind and your brain to other pieces of information, it can also create connections across people that weren't there in the first place. So I'm hoping this serves both of those things to find the people who are close to you and to find people who may be distant from you in some ways.
Yeah, no, I love that. It's a really great ethos to kind of exposure to the unknown is a really, I think, what's that great line? As we grow, we and we age, we become trapped in our own expertise. And I think being able to kind of like bring ourselves out of the terminology that we use, or maybe a better way of saying it is to remind us that the way that we like the answers to look isn't the only way for them to look. And there's different types of assumptions you can make. There's different types of perspectives you can take. And when we're dealing with something as complicated as like the problems you're trying to make progress on, mental health problems, these are extremely difficult, nebulous, context dependent, scale invariant problems that don't have a simple one-shot solution that comes from one technology or one approach. So I think this idea that you're speaking of kind of opening up to the serendipity of the community is kind of required if we're going to make really important progress on these difficult problems. Is that something that resonates with you?
Absolutely. And I think we're in, again, in this space and time and technology where there are technologies that can look across this vast landscape. So I wanted to give both this in connection between the technologies that can look at this landscape and the human connection to it, which is to see
Yeah.
who is studying what do they know, why are they studying it, and so really it's this meshing of two worlds that I'd love to bring together through this lens. Anybody who's gone and done a search, at least in many spaces, will realize that they're given a very narrow view of that space.
Yeah. Yeah.
Now you can look at, let's say, Sydney and its local set of things that are happening, but in the context of Brisbane or some other place. And
Yes.
so
Yes.
that relationship also allows you to kind of navigate the space in a slightly different way.
Yeah.
You're getting to see fields that are close and far, and you can try to understand why are these fields so close and far in this mathematical representation. And I want
Mm.
to emphasize that this is a mathematical
Yeah.
representation. This is unlike the physical space I've been talking about with respect to California or Boston or Sydney or
Mm.
Brisbane.
Mm. Mm.
This is a space that we can shape. We can understand how to kind of say what kinds of relationships between things are important and how do they cluster together. So I think that's something, again, a little bit with my scientific hat on is part of this exercise as well, is why should things be related? Uh, and how did we get there?
Yeah, it's funny. So I share your interest and enthusiasm for this. I just found myself wondering while you were speaking what the optimal solution to the embedding physically would be. And because you could imagine if you, let's say you found the this semantic space and you were able to cluster it perfectly. Let's imagine this miracle world where such a thing exists. And then you placed the dynamic functional connectivity people over in the left corner, and you put the psychiatry people over in the right corner. Um, if you made it too sort of community based, in a way, you'd almost be giving up on the serendipity. And then, but if you went the other direction and you put people just randomly, like imagine you tried to increase the entropy of the network, you wanted to place people, the most odd people you could. The benefit of that would probably be that everyone would get fit because they'd have to walk halfway across the poster hall to see the posters that they had underlined. So there's some trade-off there, I think, between perfect order and complete disorder that we also probably need to think really carefully about as a community. What do we really want to promote? What is the right amount of disorder to sprinkle into the order to bring it the bring what we're looking for here? And maybe that's something that we should discuss as a community as well as this goes forward.
Absolutely. I think this is where OHBM is a smaller conference than, let's say, Society for Neuroscience, right? And you've given me ideas about how to improve people's health, perhaps at conferences by taking a random walk, or
Yeah,
take
yeah.
random walks through various poster things. I'll keep that in mind and for the future. Uh, I think some of this is this balance between what is related. You use the example of dynamic functional connectivity on one side and psychiatry, but there are people in psychiatry using dynamic functional connectivity, right?
Yep.
And this is where I like the fluidity of the mathematics that allows us to reshape these connections. And this is where
Mm,
maybe the
mm.
virtualness rather than the physical layout constraint is important for us to understand, because now we can connect the people who are related to each other through that virtual space
Yeah,
rather than the constraints that a 2D layout on a physical floor
yeah,
gives us at a conference. And
yeah.
they can look at that virtual space, find, and this is something that this tool allows, find things that are related of interest, and then go and visit them, understanding which things are connected through what lens of semantics or meaning.
Yes, yes. No, I think that's right. The cost of sorting a list online is trivial as opposed to having to reorganize the poster hall again to make it like this. That would take, a day to do. And so we can kind of leverage the strengths of each one to kind of help the other. Um, One of the things, so there's a couple of things that Mario did with his analysis that I wanted to kind of pick your brain about, and it might be the case that you haven't done these types of things, but I just think there's such interesting possibilities for the future as well if we haven't yet done them. So one of them is that Mario imagined sort of two areas that he knew, maybe an area he knew something about and an area he wanted to know something about that maybe was semantically far away. So let's just take let's say you're a psychiatrist and you study borderline personality disorder and you want to know whether dynamic functional connectivity that you've heard about would be helpful for you studying that. But you're not a statistician, you're not an imager, you don't have any of that expertise. What you could potentially do is find a series of papers between those two spaces that each of which you knew a little bit about. You kind of each one is a short walk for you semantically. So you could go, oh, borderline personality disorder, shares some features with some other psychiatric condition. That condition also is like this other healthy cohort. That cohort had the imaging done, and that imaging was on this. And so now you can kind of see the path. And I wondered if you'd looked at that yourself, or had any ideas there for people that are going to the conference that might be in that sort of same space. Can they use this as a kind of stepping stone to help them understand a concept?
They could, but I think there lies the trickiness of some of these embedding and mathematical spaces.
Mm,
Uh, we kind of need to understand the shape of these dots in this space in
mm,
certain ways, the
mm,
geometry, how they relate to each other. The example I'll give is uh, again, taking the analogy of the Earth, you could go from one city to another using roads, and you could fly from one city to another, and you could hop in different ways. And the
Mm,
geometries
mm,
are
mm,
different. The
mm.
ways we do this is different. And the
Yeah,
same
yeah.
thing kind of holds in this kind of space. What is it that next hop that you're looking for? And this is one of the things I found as a result of doing some of this work is that a lot of the meaning in these semantics are driven largely by clinical disorders or categories of neuroscience
Ah,
in certain ways. So one of the elements I did that was different from how Mario approached this originally was I took just the method section of the abstract and used it to create a map. And I was expecting it to be very different
mm,
originally from
mm.
the whole abstract being taken to create the atlas.
Yeah.
Because I would say, oh, maybe this relates people who are using common methods closer
And they would
together.
never think, yeah, yeah,
But
yeah.
it didn't quite turn out that way.
Oh no, okay.
I think the way communities use methods, the way that we use data sets, they still converge at certain levels. So what we
Gotcha.
largely got out was still kind of the clinical disorders that were dominating the meaning of the separations in this space.
Gotcha.
Uh,
Gotcha.
so I love Mario's trajectory idea, and I think he has something online that allows people to explore this in the neuroscience space. And it's one of those features I think would be easy for us to add to this. In fact, in one of our channels, somebody asked about how
Oh,
do we go through. I think it was Todd Constable who said, how do you create a trajectory through this space?" And I think some of it is you should just do it yourself instead of a mathematical
mm,
tool that
mm,
does this.
mm, mm.
The space is laid out so that the concept that Mario talked about in that tool is somewhat embedded in that visual information space. So
Yes,
you
yes.
you could kind of go through and navigate that space yourself to know how to make that jump. Does the title or the abstract make sense to me to make this short jump, right? And
Yeah,
and that would allow you to make maybe more distant jumps as opposed to a tool that might
yeah.
take you more stepwise through certain things.
Yes, yes. No, I like that idea. And I think that sort of underlines the fact that really at the end of the day, this is meant to be a tool for people to use. And I saw a comedian making a joke at a commencement address about someone that he sent a book of, it was like the summarized version of Buddhism. And then they put that into AI and said, summarize this for me. And the point was the person had missed the point, which was that in order to get the benefits of that, you had to actually kind of go through the process of actually doing the things. And so I think this is a good example here where if you're a student that's in a space and feels maybe like you're sort of overwhelmed by the complexity of things, you can use this tool and you can say, where's my abstract and where's another abstract and how could I navigate through it and go and do the work of looking at the next ones around you and saying, oh, that one's actually something that I know a bit about. And now you can kind of use this practically for yourself rather than just, it's not going to give you the answer, but it gives you the tools you need to get a better answer. And I think that's a really nice way to think about it.
I think that's a key point in how we are kind of thinking about this abstract atlas. Every piece of science has become more complex.
Mm,
We are either using more advanced methods. We make the assumption that we already know various pieces of knowledge. So when students come into a lab or a space, it kind of is overwhelming, kind of going back to how we started this conversation. Uh,
yeah,
in the past, that overwhelming notion could have been at a conference. Sometimes, and I see this in people around me sometimes, that it's even within a lab that it gets overwhelming because the
yeah.
amount of knowledge you now require to get started on something
Mm.
is a lot more than what it was 20 years ago.
Oh, yeah.
Uh, and so we hope that this tool and this kind of navigation of the semantic space of neuroscience also acts to help people kind of understand what were people talking about in this space back in 99 or 2000, right? So
Yeah,
this allows
yeah,
us to kind of go back near a spatial space back in, oh, what were the methods they were using back then when they were talking about this study? How
yeah.
have those methods shifted over time? How have the questions changed? What did we not know back then? What do we know now? And so I think that's what I would love to see this being used for is both for, as an educational system in getting people more up to speed, but also to
Hmm.
give them a view of that history the trajectory through which science has iteratively improved our understanding in some spaces. So you bring up a great point there that part of this is really around the complexity of science that we do. And
Mm.
as we dig in, it simply seems to get more complex than less.
Yes, no, I couldn't agree more. I was just resonating completely with what you said. I feel for the new people that join the lab when they join, they're just faced with this inundation of terminology, and all the people that have been for a little while are just having a high level conversation about some really difficult, nuanced thing that we're trying to solve. But you have to stop and think, oh no, we've got to bring everyone else along for the ride too. Otherwise, we'll just fizzle out. And so we have this constant challenge. And I think a responsibility as scientists in a community to ensure that the coherence of our field is at an all-time high. So I really resonate with what you're doing, Satra. So I wanted to finish maybe by asking you, if there's anything else that you think we've left out, and maybe if then having you reflect on how you think you've used this to see your work in a different light, and how you'd like to see this going forward.
Let me start on the last question, maybe on how I'd like to see this going forward, because I'd like
Sure.
to see this happen as a community, right?
Yeah.
As OHBM and members of that society have always done, we want to kind of extend things as much as it will help people.
Yeah.
Neuroscience is a broad space, and when I study mental health, I have learned it's not just computation. It's not just neuroscience. The
Mm,
brain lives in a body, there are interactions there. Live in an environment, we live in social circles, and there's a
mm,
very complex connection of things that influences some of the things that happen in our brain.
mm, mm.
Uh, and to solve those problems, we need these connections. We need to understand, and we need to go across the planet, I think, to understand variations, even locations, the environment, right? Somebody living in 46 degrees Celsius weather for half the year may be very different from somebody living close to freezing weather for half the
Yeah.
year.
Oh, yeah.
Uh, and so we live in the context of us, and our tools and technologies have limited us in certain ways to explore certain things because we can't scale out and study everyone. We can't scale out and study every brain with all the tools we have. And
Mm,
so this virtual space allows us to, I think, navigate that complexity in a way to understand where those relationships are. And I'd like to have people who know a lot about these spaces kind of bring that. One of the reasons we started with abstracts is abstracts kind of represent the cutting edge of science. This is why people are going
mm,
to conferences
mm.
presenting some of these things. Published literature presents kind of the historical synthesis of knowledge. And this is a mesh between those two things.
Yeah.
And so I would love to see that continue to happen where we can spread current knowledge more rapidly through this space. So I want this to become a living thing, not just related to abstracts and papers, but what's going on in labs and journal clubs and other things. I'd like to see that dynamic connection, this evolve into that constant evolution and filtering of knowledge and information. If
Yeah.
I did something in our group that helped solve some problem, I'd like to surface it as quickly as possible where somebody else does not have to go through that same process.
Yeah.
Sometimes that process is useful for learning. So I encourage everybody to go
Yes, of
through
course.
some process. But there's certain things that you can communicate, and if it got communicated quickly, it would shorten the loops in science, right? And shortening those would allow us to speed up certain things, put up gain in how we progress in science a little bit more. So I hope that's where we end up, where this becomes kind of a living body of knowledge that
Mm,
connects to the older non-living body of knowledge, perhaps,
yeah.
and
Yeah.
allows us to navigate it for the complex problems we solve.
Well, that's a fantastic note to end on, Satra. What a pleasure to chat with you, and thanks again for you and your team's hard work in putting this together. I unfortunately will not be in Bordeaux at OHBM this year, but I look forward to hearing about all the great times you all have together. And yeah, thanks for taking the time.
Mac, we'll miss you, but hope to be in touch through other meets. Thank you
Great.
for having me.
All right, see you, Satra.
See you.
The Transmitter.